Topic 3, first order differential equation. We will learn 3.1 separable variable and 3.2 first order linear differential equation. And the learning outcome, students should be able to distinguish between general and particular solution, solve separable differential equation, and solve first order linear differential equation by means of integrating factor. Okay, so definition, a simple type of differential equation is dy dx equals to x squared plus 9. We integrate it to produce the required solution. Okay, a differential equation dE is one which relate an independent or dependent variable with one or more derivative. These are the example of differential equation. Okay, this one the example. And definition for order, the order is the highest derivative in a differential equation, and the degree is the highest power of the highest derivative which occur in a differential equation. For example 1, determine the order and degree of differential equation below. So the first line, dy dx, okay, this one dy dx, the highest is dy dx. Okay, the highest derivative in a differential equation is first derivative. Okay, that's why the order is 1, and the degree, the highest power of the highest derivative, so power 1. So this one your definition, the order, the highest derivative in a differential, and degree, the highest power of the highest derivative in a differential equation. Okay, the second one is, okay, look at the example, the second line. Okay, the highest derivative is 2. Okay, the highest derivative is 2. Okay, that means second derivative. That's why the order equals to 2, and the highest power of the highest derivative we call the degree. Degree equals to 1. So next, the highest derivative. Okay, this one the highest derivative is 3. Okay, the highest derivative is 3, and then the power for the highest power of the derivative is equals to 4. Okay, that's why the equals to 4. The next one is the highest derivative. Okay, the highest derivative is equals to 1. This one equals to 1, and then the degree for the highest power equals to 3. Okay, so equals to 3. That's why the degree equals to 3. And next, the highest derivative, that means the degree, the highest derivative equals to 2. Okay, that's why the order equals to 2, and the highest derivative in a dE in this example equals to 4. Okay, that's why the degree equals to 4. And the last one is the highest derivative equals to 1. Okay, the highest derivative, this one equals to 1. That's why the order equals to 1, and then the degree of the highest power of the highest derivative equals to 5. Okay, in this chapter we only deal with first order and first degree differential equation. Okay, how do we solve first order differential equation? So there are two methods which can be solved to solve first order differential equation. So they are separable variable and integrating factor. Okay, the first one, differential equation with separable variable. Okay, differential equation with separable variable. The separation of variable method is used when a differential equation can be separated algebraically. So step to solve the differential equation with separable variable, we have the only two steps. The first step is separate the variable x and y. That means x by the side of dx and y by the side of dy. The second one is integrate both sides independently. Okay, and then there are two types of solution. The first type is general solution. That means general solution of a differential equation contains an arbitrary constant C. Then particular solution of a differential equation contains a specific initial value problem, and then containing no constant. Okay, so example 2. So we have two terms exclude constant. So 1, 2, 3. Okay, we have two terms exclude constant. So normally we can solve by using separable variable. This one the constant. Okay, so we have the 1 and 2. Okay, so we can use the separable variable, and then we try to separate the variable x by the side of dx and y by the side of dy. Okay, so we try in y squared dy equals to negative x squared dx. Okay, separate the variable first, and then the second one is integrate both sides. Okay, we can integrate both sides. Okay, so integrate for left hand side, we get y cube. Okay, integrate y squared, we will get y cube over 3 equals to integrate negative x cubed, we get negative x to the power of 4 over 4 plus c. And then we find y as a subject. So y cubed equals to negative 3 over 4 x to the power of 4 plus 3c, that means c. Okay. Okay, we call this one the general solution because we have arbitrary constant c. Okay. So next, B, sin x over 1 minus y dy dx equals to cos x. Okay, so this one we have two terms. Okay, 1, 2. So we can use the separable variable. Okay, so first try to separate the variable first, then separate the variable sin x dy dx. Okay, this one is question 1 minus y equals to cos x. Then separate. Okay, separate x by side of dx and y by side of dy. Okay, so cos x, okay, over sin x dx. Make sure dy and dx berada pada numerator, and then 1 over, okay, this one 1 over 1 minus y dy. Okay, then the second step is integrate both sides. Okay, integrate both sides. Okay, so the left hand side we integrate, we get 1 over ln. 1 over 1 minus y dy, we get ln 1 minus y, okay, over negative 1. This one over negative 1, so we get negative ln 1 minus y. Okay, equals to integrate a cos x over sin x, we can use the properties or you can use the substitution method. Okay, so maybe you can use the properties. Okay, differentiate d dx. Okay, differentiate d dx. Okay, sorry. You can use the properties d dx f prime x over fx equals to ln fx. Okay, so you differentiate sine, we get cos. So that means we get ln sine x plus c. Okay, by using the properties, and then you can use the substitution method. Okay, so then you find y as a subject. Okay, so ln 1 minus y to the power of negative 1 equals to ln sin x plus c. Okay, then we get ln 1 over 1 minus y equals to ln sin x plus c. Okay, then try find y as a subject. We get try to exponent both side. Okay, exponent both side. So exponent ln, we get exponent ln 1 over 1 minus y equals to exponent ln sin x plus c. Okay, so by using the properties, we can simplify. So, simplify exponent ln, we get 1 over 1 minus y equals to exponent ln sin x plus c. That means we get exponent ln sin x, okay, dot exponent c. Okay, dot exponent c. That means exponent c we can use as a. Okay, so 1 over 1 minus y equals to exponent ln. We can simplify equals to sin x. Okay, sin x multiplied by exponent c equals to a. So 1 over 1 minus y equals to a sin x. And then find y as a subject. So 1 over a sin x equals to 1 minus y. Then y equals to 1 minus 1 over a sin x. Okay, this one we call the general solution. Okay, next example 3. Find the particular solution of the differential equation 1 plus sin squared x dy dx equals to exponent negative 2y sin 2x, where x equals to 0, then y equals to 1. Okay, this one, first calculate the terms. Okay, we have two terms, so normally we can solve by using separable variable. Okay, so separate the variable first. Okay, we can separate exponent negative y. Make sure dy on the numerator. Exponent 2y dy. Okay, exponent 2y dy equals to sin 2x over 1 plus sine square x. Okay, so we separate dia punya variable first and then integrate both sides. Okay, the second step is integrate both sides. Okay, so this one miss your dx. Okay, sorry, miss dx. Okay, so integrate both sides. For left hand side, we integrate exponent to y. Okay, exponent to y, we get exponent to y over 2 equals to integrate sine 2x over 1 plus sine square x dx. Okay, maybe you can use the substitution method or you can use the formula. Okay, the formula differentiate f prime x over fx, you get ln fx. Okay, so maybe we can use the substitution method. First, u equals to 1 plus sine square x. Okay, then differentiate, you get du dx equals to 2 sine x cos x, and then du as a subject 2 sine x cos x dx. Okay, so sine 2x, by using trigonometry properties, sine 2x equals to 2 sine x cos x. Okay, so integrate to sine x cos x over 1 plus sine square x dx. Okay, so 1 plus sine square x, you get u. Okay, this one u, and then du equals to 2 sine x cos x dx. This one du. Okay, du. So integrate du over this one, we substitute as u. Okay, so for left hand side, e 2y over 2, sorry, e 2y over 2 equals to integrate 1 over u. Okay, integrate 1 over u du, that means you get ln u plus c. Okay, for left hand side, we just copy. Okay, and then don't forget substitute u equals to 1 plus sine square x. So ln 1 plus sine square x plus c. Okay, so this one we call the general solution, e 2y over 2. Okay, this one we call the general solution, and then the condition is given where x equals to 0, this one x equals to 0, then y equals to 1. You just substitute the value of x. Okay, when x equals to 0 and y equals to 1. So substitute your x. This one x, then the value of y. Okay, equals to 1. So e 2 multiplied by 1 over 2 equals to ln 1 plus sine square 0 plus c, and then you get the value of c equals to exponent 2 over 2. Then we substitute the value of c into general solution, we will get the particular solution. Okay, this one you call the general solution. And then substitute the value of C into general solution, we get the particular solution. So e to y over 2 equals to ln 1 plus sine square x. Okay, then substitute the value of C, exponent 2 over 2. Okay, then try to find y as a subject. So e to y equals to 2 ln 1 plus sine square x plus e power of 2. Okay, then find y as a subject, exponent, then ln both side. Okay, ln both side to eliminate the exponent, so you get 2y equals to ln in bracket 2 ln 1 plus sine square x plus exponent 2. Okay, then y equals to 1 over 2 ln 2 ln 1 plus sine square x plus exponent 2. We call the last solution is a particular solution. Linear first order differential equation. Okay, a linear first order differential equation is one of the form dy dx plus pxy equals to qs. Normally we have three terms. Okay, the solution must be on the interval where both px and qs are continuous. Then the usual solution to the differential equation is to change it to an exact equation by means of an integrating factor. Okay, so step to solve the differential equation by means of integrating factor, we have 6 steps. Okay, we can simplify, and then the first step is S. Okay, S, that means standard form. Okay, S is standard form. Okay, the standard form is dy dx plus pxy equals to qx. Okay, this one the standard form. Make sure your coefficient of dy dx is positive 1. Okay, the second step is I. Okay, I find the integrating factor. The integrating factor is vx equals to exponent integrate of px dx. Okay, I is integrating factor. The third step is m. M is multiply. Okay, multiply both sides of equation with vx. You just multiply vx both sides. Then next step is p. P is a product rule. Okay, you just simplify. T dx, vx multiplied by y, and the right hand side you just copy vx multiplied by qx. The next step is integrate both sides. That means I. Okay, I integrate both sides. Okay, don't forget follow by dx and follow by dx. Then the last step is y. Okay, y, state y as a subject. Okay, we go to example 4. Find the general solution of the differential equation dy dx plus 2y over x plus 1 equals to 0. Okay, so first make sure the equation in a standard form. Okay, so dy dx equals to positive 1, and then the standard form is dy dx
plus pxy. Okay, pxy equals to qn. This one is standard form. So first step, we have s. Okay, s standard form. dy dx plus 2y over x equals to negative 1. This one the standard form. And the second one is I. I is integrating factor. So integrating factor, we have formula exponent integrate of px. Px is coefficient of y. Okay, coefficient of y. So 2 over x dx. Okay, so exponent integrate to x. 2 over x, we get 2 ln x. And then you just simplify exponent ln x square, and we get x square. Okay, so your Vx equals to x square. Okay, next, third step is m. Okay, m. That means multiply Vx both sides to standard form. Okay, you just multiply x square multiply by dy dx. Okay, plus x square multiply by 2y over x equals to x square multiplied by negative 1. Okay, so this one the third step. And then step number 4 is P. P is product rule. Okay, so product rule, you just simplify d dx. Okay, d dx. Okay, Vx. Vx, that means your x square. Okay, multiply by y. Multiply by y equals to, and then the right hand side you just copy negative x square. Okay, next, step number 5 is integrate both sides. Okay, don't forget integrate both sides. We have number 5, integrate both sides. So when integrate, follow by dx. Okay, integrate followed by dx. Okay, so next, number 5, we call the integrate. Okay, so integrate this one. So we get integrate and differentiate. We get x square y. Okay, we get the original equation equals to integrate of negative x square dx. Okay, so we just continue x square y equals to integrate right hand side, we get negative x cube over 3 plus c. Okay, so this one the step number 5. And the last step, 6 y as a subject. Okay, so you find y as a subject. Y equals to negative x cube over 3 divided by x squared. So we get negative x over 3 plus c over x square. Okay, this one the final step. Okay, so this one general solution for this question. So next we go to example 5. Example 5, the gradient of the curve is given by x plus y over x plus 1. So the meaning of gradient is dy dx. Okay, is, that means equal. So the equation is dy dx equals to x plus y over x plus 1. So find the equation of the curve which passes through the point 0, 2. Okay, the condition is given, that means the equation and then the solution must be in particular solution. Okay, so first we have 3 terms. Okay, you get 1, 2, 3. So normally we can use the integrating factor. Okay, so first the first step for integrating factor is standard form. So don't forget, your standard form is dy dx plus pxy equals to qx. Okay, so the first step is standard form. Dy dx minus y over x plus 1 equals to x. Okay, this one is standard form. Okay, make sure the coefficient of dy dx equal to positive 1. And then the second step is I. I is integrating factor. Okay, integrating factor, we have Vx equals to exponent integrate of Px. Px, that means coefficient of y. Coefficient of y, that means 1 over x plus 1. It's 1, y, right? So 1 over x plus 1. Okay, then don't forget negative. Okay, negative. Okay, negative 1 over x plus 1. Okay, so exponent integrate negative 1 over x plus 1, we get exponent negative ln x plus 1. Okay, and then don't forget simplify exponent ln x plus 1 to the power of negative 1, and then by using properties of, we can simplify, we get 1 over 1 plus x, 1 over x plus 1. Okay, this one, the value of Vx. Okay, so next we have the third step is M. Okay, M, just multiply your Vx into standard equation. Okay, so 1 over x plus 1 multiply by dy dx. Okay, dy dx minus, okay, this one your Vx, 1 over x plus 1 multiply by y over x plus 1. Okay, equals to 1 over x plus 1 multiply by your x. Okay, the red color is your Vx. And then step number 4 is P. P is product rule. Product rule, that means t dx, then Vx multiplied by y. So your Vx is 1 over x plus 1 multiplied by y. Okay, multiply by y equals to the right hand side, you just copy. Okay, just copy x over x plus 1. This one right hand side. Okay, next, step number 5 is I integrate both sides. Okay, so integrate, don't forget, followed by dx. Integrate, followed by dx. Integrate, followed by dx. Okay, so left hand side, we get integrate and differentiate. We get 1 over, or maybe we can use y over x plus 1. This one left hand side equals to integrate of x over x plus 1 dx. Okay, so for right hand side, how to integrate x over x plus 1 dx? Okay, how to integrate? So we can use maybe the substitution method, or we can simplify first. Okay, so simplify, maybe we can use the long division first. Okay, x over x plus 1, you get 1 x plus 1, and the remainder is negative 1. So how to write? We get 1 minus 1 over x plus 1. Okay, so before we integrate, we simplify first. Okay, we get 1 minus 1 over x plus 1. Okay, followed by dx. And the left hand side, we just copy. Okay, so integrate 1. Okay, this one integrate respect to x, we get x minus integrate 1 over x plus 1 dx, we get ln x plus 1. Then plus c. Okay, so left hand side, y over x plus 1. Then the last step, number 6, is what? Okay, y as a subject. So you just find y equals to x plus 1 in bracket x minus ln x plus 1 plus c. Okay, this one is called the general solution. Okay, but the question, the condition is given. That means your point x equals to 0, just the value of x, and then 2e value of y. Okay, then you substitute the curve passes through the point 0, 2, x equals to 0, y equals to 2. This one the condition, alright? So just substitute the value of y equals to 2, and then the value of x equals to 0. Okay, and then we get the value of c. Okay, 2 equals to 0 plus 1, 0 minus ln 0 plus 1 plus c. And then calculate, we get c equals to 2. And then you substitute the value of 2 into general solution, we get the particular solution. And the last step, y equals to x plus 1 multiplied by x minus ln x plus 1 plus 2. Okay, this one is called the particular solution.